this video. Today we're going to be looking at some sequence and series exam questions. So kind of the one thing to note about the sequence and series questions is that the actual kind of material is relatively easy because a lot of the stuff we need to know is on, let's say, the log tables, so page 22 of the log tables. However, whenever we have something that's kind of easy to understand or easier to understand, it generally means that the way the questions are phrased and worded and the questions were asked can be a bit trickier. And the question I'm going to go through is kind of a prime example of that. So it's 2015 question 1, and we'll just get started now. So here we have the question, and it says Mary threw a ball onto level ground from a height of 2 meters. So what we see is we're starting here. Each time the ball hits the ground, it bounces back up 3/4 of the height of the previous bounce, as shown. So just kind of from looking at that, the max height we have is 2, and then once it bounces, it will become 3/4 of, let's say, the 2 height, and then 3/4 of this again, then 3/4 of that again, and 3/4 of that again. So that's what the max height would be. So the first question we're asked is complete the table below to show the maximum heights, and they're asked in fraction form reached by the ball on each of the first 4 bounces. So you just want to make sure that we're doing the fractions. So what we see is that the initial starting point is 0 because it's before we do any bounces when we first kind of drop it. And then what we're going to have is we're going to have 2 multiplied by 3/4. And then what we have here, so there's kind of a few ways you could do it. So it's 3 multiplied by 3/4, and then multiplied by 3/4 again. Then here, 2 by 3/4, multiplied by 3/4, and then multiplied by 3/4 again. But I'll show you kind of an easier way to do that. So the other way you could do it is you could basically say 2 multiplied by 3/4, put that in your calculator, and you'd get 3/2. And then you could just do 3/2 and multiply it by 3/4, and then get your answer like that. Or what you could do, another way to do it, is to just kind of simplify the original process, which was 2 multiplied by 3/4 squared. And then this would be 2 multiplied by 3/4 cubed, and 2 multiplied by 3/4 to the power of 4. And by using it this way, we can see that what we're really looking at is kind of a sequence, a geometric sequence, because we're multiplying each time, and we can see that it's going to get smaller because number 1, we can see it from the visual that the max height gets smaller each bounce, but we can also see because whenever we multiply by a fraction, it gets smaller as well. So if you put these into your calculator, you get 9/8. So there's the 3 different ways I showed you could do it, but you'll get the same answer. 27/32 and 81 divided by 128. So that's your answer with a small bit of working out. Of course, you don't need to show the working out, but I would if I was you. It just kind of makes it easier. So now what we're asked is we need to find in meters the total vertical distance, so up and down, the ball traveled when it hit the ground for the 5th time. So what we're basically looking at is, if I just drop it up to try and fit the whole screen. So we have this part here, which is 2. Then you have this part 2. So what we can see is that the max height is what, 3/2, but this occurs twice. So the distance up is 3/2, and then the distance down is also 3/2. So you can just multiply this one by 2. Then kind of using the same logic here, the max height for this is 9/8, but again it's happening up and down, so it's multiplied by 2, and so on and so on. So 1, 2, 3, 4, and this is the 5th bounce. So 27/32 multiplied by 2 and 81 over 128 multiplied by 2 as well. So we can just put that in. So 2 plus, and then we can just do 2. So like factorize it by 2, let's say, just to speed it up. And that's basically the exact same way you do it. And if you put that into your calculator, and it says that it's looking for it in fraction form, the answer you get is 653, and you divide that by 64. So 356 divided by 64 is our fraction. So that's probably the easiest way to do that question. So now, if the ball were to continuously bounce indefinitely, find in meters, so we need to find in meters, so I probably should have put meters down here. Find in meters the total vertical distance it would travel. So again, the vertical distance is up and down, and we're looking at this indefinitely. So the first thing you need to do is look at your sequence and series kind of log table page, which is on page 22, and I'll grab that now. So here we have the log tables, and what we're going to be looking at is going to be looking at indefinite sequence, which is this. Okay, so it's given that it's given that r is less than 1, and we know that the r is the common ratio, and that was 3 over 4. So we want to basically use this one, but even before we do that, I might just create this one just so we can use a formula basically for however many bounces we want, and then just by knowing this I can then fill in for a and r over here. So I moved everything over here to make it a bit easier. So what we want is to get, let's say first, s of n equals a multiplied by 1 minus r to the power of n all over 1 minus r. So we know that the common ratio, so what are we multiplying it by every time? Well, 3 over 4. What's a? Now, this is where it gets a small bit tricky. So, well, a we know is the first term. However, our first term isn't exactly 2, because that's not really where or let's say it's not really kind of part of like this pattern, for example. So what we really want to be doing is you want to focus on just the bounce. So if we're just kind of focusing on the bounce, what's really happening is we're starting, let's say here at 3 over 2, okay? And then we multiply by 3 over 4. And then we get to this here, which is the 2 by 3 over 4. That will give me 9 over 8, and so on and so forth. So basically what our a is going to be is 3 over 2, because this is kind of where we start using our formula, whereas kind of this 2 is isolated because we don't start here and move up to here. We're actually starting at height. So if you get me, our kind of pattern starts only on this block here. And that's where I say that the sequence and series, the trickiest part about it is when we have, or the way the question is laid out and the type of question they asked us, because the material itself isn't very tricky, it's more so the way the question's asked. So what we can basically do now is, because we had the 2 is isolated, so it still travels. So if they add on this 2 plus, so what we're really doing, again, if we just have a quick look at the graph, we're going to have to count the up and the down. So we basically have 2 of the geometric formulas going. So we just have the 3 over 2 by 1 minus 3 over 4 to the power of n over 1 minus r. And then we have another one, so this is just for the up, and this one here is for the down, and it's the exact same because it literally travels the same up as it does down each time. So 3 over 2 by 1 minus 3 over 4 n divided by 1 minus r. So that's just if you didn't really understand exactly where we're going with this, because we have 2 of the same thing, what we can basically say is this again, this 2 is isolated, plus 2 times 3 over 2 by 1 minus 3 over 4 n divided by 1 minus r. So this 2 represents both the up and the down movement, essentially. So what we're then left with is this 2 will cancel out with that, and we're left with 2 plus, I'll just write it above, I'll just move this stuff here. We're left with 2 plus 3 and 1 minus, so our r I should have said was 3 over 4 down here, by 1 minus 3 over 4 to n. So this is basically our formula for s of n. But that's not what we're interested in. What we're interested in is x, or s to infinity. So again, it's the same thing. We're still going to have to keep our 2 because that's isolated, plus, again, we can do the 2, which represents the up and the down. And 2 multiplied by, so it's a divided by 1 minus r. So our a was 3 over 2, all over 1 minus r, 1 minus 3 over 4. So that basically gives me s to infinity equals 2 plus, and if you put that into your calculator, this bit here, what we end up getting is 12. So s to infinity is 14. So again, it's very tricky because the material itself wasn't too hard. Everything was in the log tables, but the actual thinking behind it and the problem solving skills you need to have is a bit, I guess, needs to be very good, and you need to kind of be focused and kind of understanding what they're asking. So this was basically isolated. This bit here was isolated. And then we have both the up movement, which was, let's say, one sequence, and then the down movement is another sequence. So by combining them together, you end up just getting that 2 that we had kind of here. So that 2 represented the up and the down. And then kind of after you realize that, then it was actually an easy enough question. Now you didn't need to do all of this where I got kind of the s of n. You could have just jumped straight into the s to infinity, but you would have needed the same kind of thinking where the 2 was isolated and that this 2 represented the up and the down. So that's it for this question. It's actually kind of a short enough question if you knew what you were doing, and the real kind of confusing bit is just really looking at the visual and seeing, well, what do I really need to do? So that's definitely a tricky one, but it should kind of open your eyes to see that the exam questions can be hard, but the more you do, you kind of start seeing things like this, and it becomes easier to answer and easier to spot as you're going. So that's it from me. Thanks everyone for watching, and I'll see you in the next video when we're going to be going over another exam question for a sequence and series. Thanks for watching.